Hi everyone, I wanted to do an example from modules 28 and 29. So first, let's open up the worksheet. So if you go to week 15 and you click on the week 15 module 28 and 29, you'll have that document. And then you'll also need the confidence interval, .xls. So for this example, I want to do a confidence interval of a paired difference. So let's take a look at the problem. So we're on page 16, and this is about an Iowa test of basic skills, and this is for third graders and fourth graders. So if you read through it, we have 10 random students where their scores were selected from third grade and fourth grade on this Iowa test. One of the key features here is that we only have 10 students selected. So our sample size is 10, which is technically not large enough to meet the T-score criteria. But because of this information right here, because we can assume that the differences are normally distributed, we can continue with this example. So first of all, is this an example of paired data? Yes, since both scores correspond to one student. Alright, so the next one. Suppose that the students improve their reading scores from grade 3 to grade 4. Would you expect the differences in their scores to be 0, positive, or negative? Alright, so since hint, we are subtracting the fourth grade minus the third grade, and improvement would mean a positive difference, since we would expect fourth grade scores to be greater. Alright, so now it says determine the differences for each of the, and fill in the table, the last row of the table. And then they want to determine the mean of the sample differences. Okay, so I did this on a separate Microsoft Excel worksheet. And let me just show you those differences. If you want to pause the video and write them down so that you have them, you can. Here are my differences. So I copied and pasted this into Excel, and then I did a formula to subtract, do fourth grade minus third grade. And here are all the scores from this example. Then I pasted them here so that I had a vertical sample so that I could move them over into Minitab. And here's their difference in Minitab. And now I'm going to run stats, basic stats, display descriptive statistics. I am going to double click on difference and click OK. So this is if your data is not summarized. In most examples, I tell you what the mean and the standard deviation is, but not in this one. Alright, so here's my mean difference between their fourth grade and third grade scores for the same students. So we're looking to see improvement in their test scores. So let's see, we have 0.340. So let's fill that in. So mean of sample differences, which equals x bar, equals 0.340. And their standard deviation, so this, we'll call that our sample standard deviation, and that is 0.414. Determine the margin of error for this interval for 95%. So this is where we're actually going to use the template. So up here, let's go to the template. So here's the template, and I'm doing this for the population mean So the sample mean from my paper was 0.340. My sample standard deviation was 0.414. The sample size was 10 students. And the confidence interval that I wish to do is 95%. So here is my margin of error. Here is my lower limit, and here is my upper limit. Okay, so the error equals 0.296. And that's the error that's the margin I need in order to capture the middle 95% centered on the sample mean. So if I construct the interval from that worksheet, I have 0.044 to 0.636. All right, so what can you conclude about the difference in the test scores? All right, so let's write our generic conclusion, and we can say we are 95% confident the true mean difference between 4th grade and 3rd grade test scores falls between 0.044 and 0.636. What's more important is that 0 is not included in the interval. Since 0 is not included in the 95% interval, we can say that there appears to be a mean growth or mean increase in test scores. Of course, that's what we would hope to see if the students went from 3rd to 4th grade, that they actually improved their test scores and did better. Alright, so that finishes up this example from pages 16 and 17 about the mean difference. The only thing that would be different if I did one of the earlier examples is that I would have a summarized x-bar and standard deviation, which you could just use the same template to do this. Alright, I hope that helps with this example.